let's just start off by numbering them. 1, 2, 3, 4, 5, and 6. So what's their very first angle? Which one do you want to find the first? 1 through 6. 6? Okay, if you have right here 40 degrees and 90 degrees, the total is going to be 130 degrees that you're using. And if there needs to be 180, that means this guy's got to be 50 degrees. Nice. Okay, after 6, where else are we going to go? What's another easy one? 5? No. 1 is going to be your next one. Look at 1. 1 is going to be easy because if this is 90, so is that. And if you're using 35 and 90, you're using 125. So what's 180 minus 125? 55. And 2 is a freebie because 1 and 2 are congruent angles. So if 1's 55, 2 is 55. And now let's go 5. Because this is also 90, and if 2 is 55 and that's 90, what does 5 got to be? So it's kind of the same as this little triangle, angle 1, 35, and 90. So 5 is 35, right? Now you've got to look at the big triangle. Look at this big one right here. You know 6 is 50, and you know 1 and 2, if you add them together, it's 55 and 55, that's 110. So 110 and 50 is 160. So how big is 3? 3 has to be 20. And now if you know 3, you can get 4, because 90, 20, so 4's got to be 70. Did you guys all get 1 through 6 right? Okay, on 14. Draw this above it. Let's draw an isosceles triangle. Because this perpendicular bisector is kind of the same thing as an isosceles triangle. Put a little star and write this down. The angles, and let's abbreviate, let's use that sign, the angles. The angles opposite the congruent, and let's use the symbol for congruent. So the angles opposite the congruent sides are also congruent. So anytime you see an isosceles triangle, Cassie, if 2 sides are congruent, here's what you know already. You could take this to the bank. This angle and this angle are also congruent. Or if they give you this, what if they give you this? What if they give you this angle is congruent to this angle? What do you know? That this side must be congruent to this side. So look at this point right here where 2, 3, 4, and 5 all meet. And look at this point where 7, 8 meet. Here's your theorem, your perpendicular bisector theorem. These 2 points land on perpendicular bisectors because this line right here hits it at 90 degrees and it cuts it in half. So it's your perpendicular bisector. That means this. This segment right here, put 2 dashes on it. And this segment right here, put 2 dashes on it. So the distance from this dot down here is going to be the exact same as from this dot to this dot. Go up to the point on 7, 8. You have an isosceles triangle. Put 3 congruent marks there, and let's put 3 there. So anytime you got perpendicular bisector, you got an isosceles triangle. Now, here's what's helpful about an isosceles triangle. Let's go 1, 2, 3, 4, 5, 6, 7, 8. Do you see angle 25 right here? What is going to be congruent to angle 25? Angle 1. So we just got 1 for free. Angle 1 is 25 degrees. So Cassie. Look at this. Let's look at the big angle right here. This is 20 and this is 25. What is 20 plus 25? So the big angle is going to be 45. Look at your big sides. Let's look at this big triangle right here. This side is congruent to this side, so that means if this is 45, this has to be 45. So we also just got 6 for free. How big 6 got to be? 6 has to be 20 degrees. Alright, we got 1 and we got 6. Where do you guys want to go next? Let me erase some of this stuff. 7? How are you going to get 7? Here's a way you could get 7. So here's what you're doing. This is 45 and this is 45. So you're looking at the big triangle. Okay, if this is 45 and this is 45, how much have we used? 90, and you have to use 180. So how big is that big angle got to be? So it's got to be 90, and you're cutting it in half. So 7 and 8 you just got. 7 and 8 are each 45 degrees. 45 degrees. Okay, perfect. So now if you got 7 and 8, where do you want to go next? What ones do you look? You can get 2 and 3 pretty slick, because if this is 25 and this is 90, what's 25 at 90? What's 180 minus 115? So 265. 3's got to be 65. And what about 4 and 5? Same. Just do 20, add angle 4, add angle 7. And we know angle 7. So what's 20 at angle 7? What's 20 and 45? 65. What's 180 minus 65? Is it 115? So 4 and 5 are both 115. Okay, that's section 5.1. With that in mind, it's pretty slick. You need to find the distance from G to A. From G to A is the exact same as G to B and G to C. So if this guy's 12, that guy's 12, that guy's 12. They're all 12. Number 2, they give you this, the circumcenter. As soon as you see circumcenter and read it, you got to know that that point R is going to be the same from O, the same from Q, and the same from P. And if it says OS is 10, let's write it in. QR is 12, so this guy right here is 12. PQ is 22, so the whole thing from here to here is 22. How long is OP? So that's this line right here. If O to S is 10, that means S to P is also 10, because this line RS is a perpendicular bisector. So from O to P has got to be 20. R to P, from R to P is the same as from R to Q. If R to Q is 12, R to P is also 12. O to R is the same. It's got to be 12 too. And the last one, what about from T to P? What's the distance from T to P? How come it's 11? Because it's got to be half of the total distance, 22. Okay, look at number 3. P is your circumcenter right here. So if this line is 13, this line is also 13, and this line is also 13. How far is it from P to X? From P to X has got to be 13. Last one, number 4. The perpendicular bisectors meet at K. That means K is your circumcenter. So I to J is 18. From I to J, that's 18 tall. From K to J is 12. From K to J is 12. How much distance goes from H to K? It's got to also be 12. And what about from I to M? If I to J is 18, this is halfway. Sweet, it's 9.